So today we would have a continuation of the introduction to cloud computing systems, and today we would discuss the most uh, mm, the most working just a second the most popular cloud computing platforms today that are providing more than a half of all the cloud computing resources to all users all over the world. We also would discuss today platforms for development of cloud computing solutions. And we also would discuss today the internal structure and the capabilities of Amazon Web Services. And if we would have time, we would try to create our own virtual machine online right now within this lecture using the Amazon Web Services. And we would go through this process step by step. So let's go to the presentation. And on our previous lecture, we discussed the levels of the provisioning of cloud computing resources and what types of cloud computing resources are available today. So you know that there are public cloud platforms and there are private cloud platforms. And if everyone is discussing cloud computing, mostly we are discussing public cloud platforms. So what public cloud platforms are available today and which of them are the most popular? Of course, the most popular cloud platform today that we should know, it is Amazon Web Services, or AWS. Amazon Web Services, it is a cloud platform from the Amazon company that was, as you remember, just an online web shop, and today it is not only a web shop, and today it occupies over 1/3 of the entire market of cloud computing resources. It is huge, it is monster. So they started development and they provided the first beta access to their resources, such as Amazon Elastic Compute Cloud, Amazon EC2, in 2006. And today, you know that this monster is the biggest cloud computing provider in the world. Second cloud computing provider that you should know, it is Microsoft Azure. Microsoft Azure, it is Microsoft's cloud platform. They introduced it in 2010 and they started actively promoting it in 2014. And since 2014, they emphasized their market share in the cloud computing market very, very much. And right now, Microsoft Azure, it is the second after the Amazon Web Services provider of cloud computing resources in the world. So they have more than 15% of all the market in the world of cloud computing resources. Next, Google Cloud Platform. Of course, Google one of the pioneers of the cloud computing technologies, but they have been a lot of late to the market. They did not provided public infrastructure as a service solutions till 2011. And since 2011, they started provisioning these solutions, and today they are in the top 3 of the cloud computing systems in the world. Of course, you remember from our first lecture on cloud computing that Google worked with IBM, and IBM right now also working in the cloud computing market with their solution IBM Cloud. They decided to go in this market in 2014. They provided their solution to the cloud computing technologies. But since then, they was not very successful in this sphere due to different factors. So IBM Cloud is also one of the solutions. And I cannot not mention the Russian cloud. It is Yandex Cloud. It is a Russian cloud computing platform from the Russian company Yandex. It is the biggest internet company, one of the biggest internet companies in Russia. So they providing their own cloud computing solution since 2018. So what is the distribution of the market today between these platforms? You can see that in 2019, so just last year, the market share of the Amazon Web Services was just above 32%. Microsoft Azure, about 18%. Google Cloud, 6% of the market. And Alibaba Cloud, of course, if you work in China, you should use the Alibaba Cloud resources. It is about 5.5% of the total market share of the cloud computing technologies. All other platforms combined, they make about less than 40% of the market. That means that all others platforms make just about like Amazon Web Services, not a lot of bigger than Amazon Web Services provide. So if you would like to create your own cloud computing solution, or if you would like to create your private cloud, or you can create your own public cloud if you wish to go to this market, so you can use some open systems, some open platforms in this area. And we would today highlight some of them. They are all very, very complex solutions that consists of a lot of layers that provide different capabilities on all the layers of management of the cloud computing resources, including virtualization, including scheduling, including storing of images, provision of images, and all this huge services catalog. These are provided by these solutions. So what are they? First of all, OpenStack. OpenStack, it is a most popular platform today for creation of clouds, private clouds and public clouds. Some of the most famous public cloud solutions, they are built on the basis of OpenStack inside. So this project is developing since 2010. And if you go to their webpage, you would see that there are a lot of public computing platforms that are providing their resource to the end customers using the OpenStack protocols. Not protocols, but OpenStack solutions and components. The competitor of the OpenStack that also provides infrastructure as a service capabilities, it is the project OpenNebula. The OpenNebula project, it is also a cloud development platform for managing heterogeneous distributed data centers infrastructures. So why I like this project? Because this OpenNebula project was developed from the research project that started in 2005. So as a researcher in the field of cloud computing, I'm very appreciate solutions that are developed from the research project. And its first release was in 2008. And this project is open source. It is very, very famous, and it is developing right now. So it is one of the most interesting solutions on the market. CloudStack, one more competitor, and it is famous because it was developed with the contribution of the company Citrix Systems. Citrix is a very famous company in the world of cloud computing and virtualization. So this platform was first released in 2010, and still it is very, very famous for the development. And in the end, I wanted to discuss these two platforms. They're somehow specific. So Eucalyptus, it is also open source software platform for building cloud computing solutions. So it is not, you cannot easily distinguish it from the others. But one feature that it provides, it is compatibility with the Amazon Web Services. So this platform allows you to create your own cloud, and your own cloud would be compatible with the Amazon Web Services, with the AWS. That means that your cloud would be just like Amazon Web Services, but very, very small. And if you launch your application on your small private cloud, you would easily transfer it, if it is needed, to the big public cloud of the Amazon Web Services. That is a great feature. And the last project and the last platform that I would like to emphasize here, it is Cloud Foundry. Cloud Foundry, it is also an open multi-cloud platform, but comparing to others in this list, Cloud Foundry provide the solutions on the level of platforms as a service. These platforms, they provide solutions in the infrastructure as a service level. These infrastructure as a service. So they are developing solutions for you so you can load and work with virtual machines. That is the bottom layer of these projects. But Cloud Foundry, it is higher level of management of the computation. It provides platform as a service solution. That means that Cloud Foundry provide you an API so you can upload your code on different languages like Java, Ruby, JavaScript, and etc. Or you can easily directly upload Docker containers to the Cloud Foundry platforms, and the platform would ensure deployment of these code snippets or of these containers and their automatic deployment and launching on the basis of the infrastructure as a service platforms like OpenStack, like AWS, like Microsoft Azure, or all other platforms. So Cloud Foundry, it is platform as a service that launches your containers and your application on the top of infrastructure as a service solutions. So using, for example, OpenStack, you can create your so let's imagine that these are your servers in the data center, and you decided, okay, I want to optimize their resource load. I want to optimize their utilization. So I want them to become infrastructure as a service. So my users would be able to launch virtual machines on the basis of these data centers resources. Then I would install and deploy the OpenStack here. OpenStack. Great. Now my OpenStack based solution, it is infrastructure as a service cloud for my users. But working with my users, that I understood that they do not need these virtual machines. All they want to provide me a code. So in Java, and they tell me, okay, I want this code to run as a web application. I don't want all this working with virtual machines and etc. I just want this code to be possible to launch in the cloud. And then I would go and I would just a second. So I would go and I would install the Cloud Foundry on the basis of my OpenStack solution, Cloud Foundry. On the basis of my OpenStack solution, and then I would provide them platform as a service solutions, so they can give me on my platform, they can get the API, they can give me their Java files. The Cloud Foundry automatically would create virtual machines, would deploy all the necessary service to these virtual machines, would get the link to the service that was launched, and it would provide this link to this server to the user. So in this case, user even do not know the URL or the IP address of the virtual machine that he's using. Of course, he can know this, but it is not necessary for him to understand how it works inside. He just provides me the Java file, and Cloud Foundry solution provides him the possibility to launch his own applications on this. So this is platforms for creation of clouds. And now let's go to discussion of the most popular cloud computing provider in the world. It is Amazon Web Services. So on this picture, you can see how the data centers of the Amazon Web Services are looking from the outside. These are just very, very big buildings with a lot of fans outside, a lot of coolers because they need to cool their computing facilities, and they are located in very, very not crowded areas to provide up to 70% of all North American traffic transferring. This is very, very big amount of traffic that goes especially through the servers of the Amazon Web Services solutions. Of course, if you ask Amazon where your servers are located and why I'm showing you this picture and why I'm so interested in this, because no one knows for sure where are they located and where are they building these facilities. If you go to the Amazon Web Services webpage, you would see a picture like this. They would tell you, okay, this is a map where our data centers are located. And somewhere here, you can see that there is some so-called availability zones. And there are some availability zones here and here and here. And where exactly address of the location of the web server or the virtual machine that they would share with you, it is unknown. They are hiding their resources, and it is not very easy to find where this is located. So you can see from this map that if you launch your application in the Amazon Web Services, you get great coverage for the United States and North America, because they have a lot of availability zones there. They have 3 availability zones in the South America. They have great coverage in Europe. They have great coverage in Asia, in China, and in Japan, in the most populated areas of India, in Singapore, and in Australia. And they're developing from year to year more availability zones to be closer to the customer of the cloud computing resources. So how Amazon Web Services started? They were officially introduced in 2006, combining 3 initial services. Amazon Simple Storage Solution, this is object storage. This is Amazon S3. Amazon Simple Queue Service, that is web message queues. And Amazon Elastic Compute Cloud, Amazon EC2. That was their new on-demand virtual servers solutions. So Amazon Web Services offers were available through REST and the SOAP protocol, and today mostly they use REST, and the SOAP protocol is in decline, and practically no one uses it. So that was 2006. What Amazon Web Services looks like today? Oh, it looks like this. They have, I think, about 100 of different, at least dozens of services for computation, for calculations, for storage, for database management, for media services, for mobile applications development, for AR and VR solutions, networking management services, a lot of machine learning solutions, analytics solutions, security solutions, Internet of Things solutions, game development solutions, a lot of different solutions. So they would give you almost all the necessary solutions you need to work with when you are developing your web service. A lot of companies today use Amazon Web Services as a basic for provisioning of their resources. Dropbox, most of their resources are hosted on the Amazon Web Services. Almost all applications, if you look of not Google applications, but for example, some Twitch and a lot of companies, they use their the Amazon Web Services solutions. Netflix, the Netflix company that provides the biggest amount of legal media streaming in United States and in the world, it also uses Amazon Web Services as the basics for the provision of their resources. So let's go and let's see what Amazon Web Services are available for the developer today. For calculations, of course, the simplest way and what we would cover today, this is Amazon Elastic Compute Cloud service. This was their first and most popular solution for provisioning of virtual machines to the users. They used the Xen hypervisor for the virtual machines development. Second, this is Amazon Elastic Beanstalk service. It provides platform as a service solutions to host the programs. So Amazon Elastic Beanstalk, this is it works like I told you about the Cloud Foundry. So you send there your source code and it automatically launches it in some containers. One more thing that we need to know about, it is Amazon Lambda. Amazon Lambda, it is so-called serverless computing platform. Serverless means that you submit your source code And this source code is launched. It works not all the time, but it works in a response to some internal or external event. So why can you use it and how do you use it? For example, let's imagine that we are hosting some video streaming solution. So to host our video streaming solution, we need to get the raw data files from the providers of the top level cinema, and these are very, very, very big files. They're big, and this is very, very high quality files, like Blu-ray quality video. And you would not be able to stream this Blu-ray quality video to every user, because this user, he has a very, very, very small phone. This user, he has like not very big TV. This user watches this from his laptop. So you can see that this user on the small phone, he needs the picture in the quality 1. This needs the picture in the quality 2. This person needs a picture in the quality 3. Different qualities of the files. This the smallest file, this is bigger, and this is the highest quality that you can provide. So when this big file arrives, it launches event, and this event triggers these lambda functions. This is lambda function 1, this is a lambda function 2, and this is a lambda function 3. These lambda functions, they get this huge Blu-ray file and they process it on the servers of the cloud computing provider. And as a result of processing, this lambda function create a smaller video file with the quality number 1. This creates bigger than this file with the quality number 2. And these create another file with the quality number 3. And they store these files. And when the person from the smallest client asks for the file, he would not get this big file because it would be unnecessary for him to get this huge Blu-ray file. There would be not possible to get this file because of the restrictions of the network. Instead, he would get this very, very small file, and he would be able effectively, and he would be able to stream it to his device, and he would be able to look at this file from his device. The same way, for example, YouTube works. If you upload your document, your your movie to YouTube, it would not store this file in his original quality. It would launch these functions to create several smaller versions of this file. And if it is necessary, it would provide you the file with the quality that is necessary for your device especially. Today, for example, when we are all sitting because of the coronavirus in our homes, YouTube told to their customers, you know, we by default, usually, we provided you the best quality. But today, because the network is so laggy, we would go and we would provide you not the best quality, but not the best quality files by default. And if you want better, you can ask us and we would provide them your better quality web files. That is how the Lambda functions work. They are creating processing power by the triggering of some events. So this is what Amazon Lambda is in the terms of calculations. Networking services. Amazon Web Services provide the following ways to organize your network. First, of course, it is the managed domain name service, Amazon Route 53. This is self-hosted of the Amazon DNS and provides host name to IP conversion. So if you need your domain name, you can use Amazon Route 53. It is quite expensive comparing to other solutions, but if you're a big business, then you don't care. You just throw your money and it works. Amazon Virtual Private Cloud, VPC, it allows you to create a logical isolated set of Amazon Web Services resources that can be combined with the virtual private network. If you host dozens of virtual machines inside the Amazon, you can combine them in a virtual network, and this virtual network would have shared network accessibility using the VPN, and no one outside would be able to go inside this network without your permission if you organize this correctly. And of course, one specific service that they provide, this is Amazon Elastic Load Balancing feature. It automatically distributes incoming traffic between many Amazon Elastic Cloud instances. Elastic load balancing or load balancing means that when you have your application, this is logically one application, but if you're developing a scalable solution, this logical one application would be scaled between several copies of Elastic Compute Cloud instances. This is 1, this is 2, this is 3, and this is 4. So one application, one logical application is distributed between 4 nodes. Why do you do this? Because if you work with one node, for example, it would be able to host 100 requests per minute. Yeah, and if your application is working with more than 300 requests per minute, then one host would not cover this ability. But how you would distribute 300 users between your hosts? You, of course, can create your own solution to distribute them, but Amazon Load Balancer, it is a standard Amazon solution that solves this problem for you. So this is Amazon Elastic ELB. This is Amazon Elastic Load Balancer, and all these users are going here. He works as a reverse proxy for them. It listens for all the incoming messages, all the incoming connections, and automatically redistributes them between the servers that you have in the Amazon EC2 Elastic Compute Cloud solution. So now your application is automatically scalable on the basis of the incoming load of the requests. That is how Elastic Load Balancing works. Data storage. Amazon provides a lot of solutions to store your data. Simple storage service, Amazon S3, it is object storage that is also scalable and available through the web service interface. When the Amazon web services, they were developed, what the developers had in mind is that the application should not store its state locally. So if we take a look on the deployment diagram, this is not a deployment, but like this schema about the deployment on the application on different virtual machines. And if the data of this application would be stored inside the virtual machine 1, virtual machine 2, virtual machine 3, if they would have their own local storage for the data, then if one of the machines fail, we would lose the data too. So that is not a way to work in the cloud. The cloud way to deal with the state is do not store your state inside your virtual machine. You should have some external storage solution that is connected with the virtual instance of your, not the virtual instance, but with your application as a whole. And this external storage solution, it can be some database, it can be Amazon S3, it can be some other ways to store, but virtual machines, they work with this storage, with this cloud storage, when they want to deal with the data of the users. So these virtual machines and cloud applications, in this case, they would be stateless. Because inside there would be no state. All the state would be here, state. And if user sends your request in the virtual machine 3, it goes to the state, it works with it, it gets back your result, and the next time user sends a request, his request is going to the virtual machine 1, it is not a problem, because virtual machine 1 goes to the state, retrieves it, and answers the user in time. So that is why storage and content delivery in Amazon Web Services is so crucial, because you need a very robust and fault-tolerant and scalable way to store your data. So Simple Storage Service provides you availability to work with objects. For example, the description of the item inside the web shop can be easily described as an object with a list of fields. So you describe the fields, you describe the object, and you can store it in the Amazon Simple Storage Service. Second, Amazon Glacier. Glacier, it is very different comparing to the Simple Storage Service. It is used for long-term storage solutions. So in the Amazon Simple Storage Service, it is designed to be very robust to read and to write the data and to read the data. Amazon Glacier works differently. You put huge amounts of data here, terabytes of data, your archive of media, and these terabytes of data are put here for archival purposes. For example, if you want to backup your data, you can use Amazon Glacier. So if you lose some of your data, you can go to this Glacier and you can ask it, okay, please give my terabytes of data back to me. So this is how Glacier works. And Amazon Storage Gateway, it is a virtual SCSI storage device with a cloud backup. Next, it is Amazon S3. So let's go and discuss this. Amazon S3, the simple storage service, it was provided in 2006, 2007. And if you open Dropbox, then your files would be stored in the Amazon S3. If you open Twitter, your data would be stored in the Amazon S3. If you play Minecraft, then to download your Minecraft installer, you would download it from the Amazon S3 service. And databases, of course, you would like not only store files, you would not only store objects, but you also would like to work with databases. So Amazon has its own database. It is Amazon DynamoDB. It is online NoSQL database with low response time. Amazon RDS provides you scalable database service with MySQL or SQL Server or PostgreSQL. Redshift provides capability to work with petabytes data storages. And Aurora provides an MySQL compatible relational database engine. So if you would like to work with databases, it is not necessary to install your own instances and launch and manage all the databases by you. You can go to the Amazon, pay them a lot of money, and they would give you automatically scalable solutions to work with the databases and to work with data. Let us discuss the capabilities of the Amazon Elastic Compute Cloud. What is it and how can you use it in your everyday life? So Amazon Elastic Compute Cloud, it is a web service that provides computing power in the cloud. And if you would like to create your server somewhere that should be available to a lot of users, you can use Elastic Compute Cloud. The service interface allows you to access computing power. It gives you a complete control over the resources and the accessible environment to work with them. When you are going to launch your own virtual machine in the Amazon Elastic Compute Cloud, you would be greeted with this huge table of the virtual machines that you can use as the basis for your web application, for your web service. You can see here that it can provide you virtual machines almost with any type of operation system. It can use Amazon Linux, it can use Red Hat, it can use SUSE Linux, it can use Ubuntu, it can use Windows. And choosing one of the operation systems to be launched in your virtual machine, you can launch it and access it through the internet. So Elastic Compute Cloud allows you to create an image from the Amazon machine image that will contain your apps, libraries, data. You can download this image to the Amazon S3 to save this image if you would like. You can use Amazon Elastic Compute Cloud web interface to customize the security and the network access for your virtual machines. You can choose a type of operation systems, identify the need to work in multiple locations. For example, if you would like your applications to be accessible in the North America and South America and Japan, then you can redistribute your virtual machines between these instances. So what is the cost of virtual machine? If you would like to book a virtual machine, then you should be able to pay for it. So the smallest one, the T2 Nano virtual machine, it is available in about $5 per month. This is a virtual machine with one virtual CPU and with about half of the gigabyte of the memory available. Why would you interested in such a small machine? For a lot of cases, if you would like to test if your application working well in the cloud environment, if you would like to provide a prototype of the application and show it to your friends, you can easily book this and pay $5 per month, and this unit would be available for you, so you can launch your application there. The next biggest instance, it is TtoMicro instance, and it would cost you about $10 a month. And depending on the load that you're expecting, you can book and order more and more business units till about $300 per month for a huge virtual machine with 8 CPUs, with 32 gigabytes of RAM, and with a lot of computing power. But this is not the biggest instance that you can order, and most expensive instances. They are very, very interesting things. They can provide you some additional features. For example, they can provide you FPGA support, so you can use FPGA accelerators to increase the speed of your calculation. You can book virtual machines with GPU graphics. For example, if you would like to provide the virtualization on the 3D engines, you can book GPU compute machines for solving the problems in machine learning. So I searched for the most expensive item that is available for you today. And so I searched and searched, and I found that P3 16X large with the GPU, 64 CPU available, more than 480 gigabytes of RAM. It would cost you about $20,000 per month, or about $24 per hour. But of course, these machines are not booked usually per month. If you are, for example, independent software developer, you book this machine on several hours, and you put your neural network there. You educate your neural network on this machine in several hours, and then you close the connection and you release this virtual machine instance. And you would pay not $20,000, but you would pay some reasonable cost, about $100 per several hours. So how would you be able to register in the Amazon Web Services? So you should know that all of you already was invited to the Amazon Web Services account using the classroom. So I created a classroom for the class that you are studying right now. And this is, let's go here. This is it. This is the control panel for this classroom. Architecture of distributed computing systems. And in the beginning of the semester, I sent every one of you your invitations to this classroom. I do this every time. But unfortunately, only 5 people using this account right now. It is $50 of the Amazon Web Services. So when you click to this room, go to the classroom, you would see this description that you would have here. Like, these are my classes, and now I have one class, Architecture of Distributed Computing Systems. So I click on this class, and I would get an access to this web page. And on this web page, I would see that this is my account status for the Amazon Web Services. And in this account services, I would see how much money do I have. So you can see that I did not use any of these credits for the virtual machines. But to spend these credits and to create a virtual machine, I can go to the Amazon Web Services console when I press this button, AWS Console. So when I go to this console, I would have this interface for the management of my Amazon Web Services resources. And you can see here that it is very, very strange name in the top. This is because I use not my name in the AWS, but I use a specific teaching account that have this $50 of the credits for the Amazon Web Services. So if I would like to create a new instance, I can go to this services tab, to the services of the Amazon Web Services, and I can click on this EC2 Compute Cloud, or I can find EC2 in this console and click on this. So this is the management of the Amazon Elastic Compute Cloud virtual machines that are available for me right now. So you can see that I have right now one running instance of this Amazon EC2. I launched it just in the beginning of the lecture to test the compatibility and to test the working with this correctly. So let's go and test how it would work if you would like to create a virtual machine in the Amazon EC2. So first, we are clicking on this button, Launch Instance. And you can see here that Amazon EC2 provides me with a set of virtual machines that I can launch in my account. Let's choose the standard Amazon Linux virtual machine. It would use SSD for the basics of their volumes, but almost all virtual machines right now in Amazon, they use high-speed SSDs as the basics of their storage devices. So let's use 64 bits x86 server select. And I would use TtoMicro virtual machine with one virtual CPU and 1 GB of memory. Of course, I can use this T2 Nano, but it is too small. And if you would like to go with some okay applications, TtoMicro, it is the minimal amount of the resources that you should use. And let's go and let's review and launch this machine. But what is it? It doesn't allow me to launch the machine because it is necessary to understand how would I get the access to the machine. Amazon Web Services does not allow you to use simple authentication like username and password to access your machine. By default, all the connections with the virtual machines, it is encrypted. So to encrypt your virtual machine, you need to create a signature. So to create a signature, I would create a new key pair for my virtual machine. This is public key and the private key to encrypt my connection and to sign me to the virtual machine. I would name this key pair a second lecture test. Lecture test. May 13. And I would download this key pair on my machine. So you can see that it is previously I already had created my pair of the private and public keys, but this time I would use a new one. So I download it, and you can just a second, and I can open this in my window here. So you can see this file with the private and the public key. It was downloaded to my machine. So what can I do with this file is I can create from this file a signature so I can connect to the virtual machine. Let's go and see how can I do this. So let's go back. We launch our instance. And you can see that the instance right now is launching. And let's go and see what are the instances of our Amazon EC2 are available for us. Let's go here, services, EC2, running instances. Right now I have one running instance, and one instance that is just initializing. That is the new instance that we created just now. So, okay, how can I access this instance? You can see here that this instance already has, just a second, this instance already has its own public IP, and it has its own, just a second, public DNS. So if I would go to this URL, I would access my virtual machine. But of course, right now on my virtual machine, no servers are installed, no web servers installed. So if I go to this web server and I check it, it would not work. It doesn't allow me to go to the virtual machine. Okay, what can I do with this? So to access my virtual machine, I need to establish a remote terminal connection, SSH connection. To access my virtual machine, we can go to this menu, right click, and press connect. So when you press connect, it provides you a support page about how you would be able to connect to this machine using your own standalone SSH client. Because we're on Windows, we can download and use Open SSH Client Putty. P-U-T-T-Y. I already downloaded it to my machine. It looks like this. So it looks like this. This is the interface of the Putty configurator. And here you provide the name of the machine, IP address of the machine, and the name of the user that you would use to connect to the machine. But before you connect to the virtual machine, you should create your own signature. So you can connect using your private key for authentication. To create your private key for the authentication, you need to use another utility that is puttygen, and it is here. It is also installed when you are installing Putty to your machine. You press load and you choose all the files, and you choose this lecture test. That I would choose my new file that I created today, lecture test. I press open, and I press save. Oh yes, I press generate. I would generate public private key pair. Oh no. That's wrong. One more time. I need to check what I'm doing. So downloads, all files, M file, open. Okay. So I need to, just a second. I need I need to save my private key. Yes. And I would save my private key here, like lecture test ppk. Saved. Okay, great. Now we have this private key that we can use. Now let's go to the PuTTY, browse and open our lecture test, a private key in the auth tab here, SSH auth. And let's go to our session and read the manual that the Amazon Web Services provide for us. How can we connect to our virtual machine? It tells us we need to use this specific username, then we need to press add, and then we need to provide the URL of the machine that was just created. We copy and paste it to our PuTTY. So you can see here that I copied it, and right now the string looks like this: EC2 user at, and then we see the DNS, the domain name of our virtual machine. We can check this if we go to the console of our virtual machine, and we see here that this is the same name, 2384.213.30, and we go to the PuTTY and we see the same 2384.213.30. So let's try to connect to our virtual machine right now. It says, okay, I do not recall this host. Would we like to save the fingerprint of this host? And I say, yes, of course. It says, okay, I connecting to this virtual machine, to this remote host using the user EC2 user. I would authenticate using the public key that I imported. And now you can see here that I am connected to the virtual machine that is hosted in the Amazon cloud. What can I do with this machine? I can do everything. I can go and see what is here on my virtual machine. I can install any web server on it, any application that I want to launch in the web. I can manage it and allow connection using HTTP and HTTPS ports. And for example, I can host my website here very easily. I would install Apache, or I would install Nginx, any other web server. I can host web applications, for example, REST service, on this virtual machine. So this is a huge possibility to everyone to create and use the resources that are available online. So in the end of the presentation, in this presentation, of course, it is available to you, and all the instructions that I just showed you live, they are provided here clearly about how to download the PuTTY, where you should click to create your private key, and how to use the PuTTY to connect to your virtual machine using this specific username and the name of the machine. So voila, you see here that it is the same, and this is available to you in the PDF that you have as the slides of this presentation. In the end, I need to emphasize that after you created your virtual machine, you need to understand that if it is running, you're paying your credits for it. If you're using your educational account, then you're paying your virtual credits. And if you're using your real account, then you would pay with your own money. And right now, you can see here, I am running 2 virtual machines that would cost me $20 per month, because each of them costs me $10 per month, because these are instances to TtoMicro. So I don't want them to cost me so much. And right now I don't need them. So what should I do with them? Of course, I need to stop. Right click. Next, we are going instance state, and we press stop. Yes, we would stop this instance. And the next, we would also stop. So now these 2 instances are stopped, and if we would try to connect to one of them, you can see here my PuTTY. My PuTTY said, fatal error, you just stopped your virtual machine and I cannot connect to it. Okay, I would understand, because I just stopped my virtual machine. So after I stopped my virtual machine, I would not pay to work with them, because they are stopped. But if you want to clear all your virtual machines, you need to terminate them. So you press terminate, and then all the data on this virtual machine would be terminated. The virtual machine would be terminated with everything that was there. So yes, here you would see the instructions how you terminate your virtual machines. And after you terminated your virtual machine, you need to go and test if everything is terminated and you have no resources that you need to pay in the end of the month. And if you have any resources, then Amazon Web Services would be glad to take your money for all the resources that you spend. So let's go and take the final test in the Amazon Web Services. The final test is open right now. I'm providing the link to the test in the chat. And thank you very much for the participation today in my lecture on the introduction of cloud computing. Goodbye.